Suppose that I'm analyzing this circuit using mesh analysis. So the first step is to label the meshes that I have. So I'll define a mesh current I1, I2, and I3, let's say like that. Then I would like to write Kerchos voltage law around each of my meshes. But if I started trying to do that for mesh current I1, then I will proceed until I come across this current source. And then what I'm going to find is I'll try and write down an expression for this voltage, but then I can't really do that because the voltage across that current source is unknown. There's no Ohm's law or anything I can use for current sources. So as a result, writing Kerchos voltage law around this mesh I1 is going to be difficult. So I need to use a supermesh. So here I need a supermesh. So a supermesh is when I draw a new path that kind of goes all the way around the this loop so that the current source is fully enclosed within that loop. So this green line that I've drawn here is my supermesh. So this enables me to analyze my circuit using KVL all the way around that loop. So use Kerchos voltage law at the supermesh, or really around the supermesh. So let's choose a place to start, let's say bottom left corner, and I'll proceed in a clockwise direction as I've drawn it. So that's a negative 100 volts for that source. Then there'll be the 3 ohm resistor. So I get to here. For this 3 ohm resistor in the direction of travel, I have current I1 and minus I2. So this is Ohm's law at my 3 ohm resistor. I proceed further around and I come to the 2 ohm resistor. So this will be 2 ohms, and then I look at the mesh currents and they are I3 minus I2. And then further around I encounter the voltage source. I'm coming at it from the positive side, so that's plus 50. Then there'll be this 4 ohm resistor, and there's only one mesh current here, so that is just I3. And then the final circuit element in my path is the 6 ohm resistor, and there'll be current I1, and that's also in the same direction of my travel, so I use a positive sign, and now I'm finished with that equation, so I get back to my starting point, so that is equal to 0. I can also use KVL around my mesh I2. So use KVL at mesh I2. And this one is fairly straightforward. We don't need any special super meshes or anything like that. Bear with me, I'm just trying to undo my highlight. There we go. So I'll choose a starting point, so let's say top left corner there, and proceed in the direction of I2. So I will have 10 ohms multiplied by my current I2 will give me the voltage across that 10 ohm resistor. The next element is the 2 ohm resistor, and there will be 2 mesh currents that contribute to its voltage, so they will be I2 minus I3. And then the final component is the 3 ohm resistor, and here I will have I2 minus I1 as my current contribution, and all of that is equal to 0. So at this point I have 2 equations and 3 unknowns, so I need one more equation to fully describe this system. And that equation will be the dynamics inside of the supermesh. So looking at the supermesh, here's what I can write down about the mesh currents. So I know that the mesh currents must combine in such a way that there is 5 amps flowing through that particular branch because there's a 5 amp source there. So looking at that, I can clearly see that 5 amps is equal to the combination of these mesh currents. And so I see that I3 is in the same direction as the current source, so there's a positive sign for that, whereas I1 is in the opposite direction. So I would write I3 minus I1. So these now give me my three equations, so equation 1, equation 2, and equation 3. So three equations that describe the three unknown mesh currents in my system. So at this point, it's a matter of solving these simultaneous equations in order to fully analyze this circuit. So in summary, how to use a supermesh. You recognize the need for a supermesh by seeing that you have a current source that is shared by two mesh currents. And so if you have the two mesh currents are both touching that current source, then you're going to need to use a supermesh. You get one of your equations by analyzing the dynamics of that mesh itself. So both the mesh currents combine to produce the current through the source. And then you get your other equation by using Kerchos voltage law around that supermesh. So you define the supermesh, just draw another path. I've drawn it in green, the longer path that goes around that current source, and use KVL around that path. And that gives you the equations that you need to analyze the circuit.